Please welcome Ryan J. Salva.
Oh, yeah. Good morning, developers, data scientists, creators, beautiful nerds everywhere. Y'all, I have been talking so much about Copilot these last couple days. My voice is a little bit hoarse, but we're just going to get through this together, all right? Yeah, I think we can do this. My name is Ryan J. Salva. I am VP of Product at GitHub, where I am responsible for GitHub Copilot. And it's hard to believe, Thomas was talking about this a little bit earlier, that we're nearly on the precipice of 3 years working with GitHub Copilot. We are quite literally the granddaddy, the OG, the original large language model product out there. I mean, it is before ChatGPT, hell, even before Stable Diffusion was out there. We were out there helping developers build and create and do wonderful things with code. One of the things that I'm really proud about as we've kind of gone on this journey together is that we have been research-led, right? We've led with research about code quality, about developer happiness and productivity. Heck, we've even led with research about economic impact. But one of the things that we've always really heard from a lot of teams is they want to know not just how it works inside of a controlled environment where we're just testing for a single variable. They want to know what it's like in the real world, where things are messy, where things are dirty, where there's reorgs and there's hairy refactoring projects and things like that. And so we actually embarked on a little journey a few months ago to work with some external companies and do a high quant study with hundreds and hundreds of developers to see what it's actually like, what impact these large language models and Copilot have on engineering teams. And so for that, I want to invite on stage one of our research partners, Dan Shockey from Accenture, to tell a little bit about some of that research. Dan, come on out, buddy. Yeah. Let's hear it. Cool.
How you doing,
welcome,
Ryan?
Dan. Welcome.
Thanks for having me.
Yeah, dude, absolutely. So, all right, I'm not sure that everyone here necessarily knows Accenture. So can you just maybe start by telling a little bit about what Accenture does? What's your business?
Yeah, sure. At Accenture, we help our customers build their digital core, transform their operations, and accelerate their growth.
Okay.
And we do that by bringing together teams from across a wide range of capabilities, many locations around the world, bring those together to help them serve our clients. Yeah. And as you can imagine, that can be a pretty complex environment where we have many developers with a bunch of different diverse backgrounds coming together, working in many different technologies at the same time to bring the best solution to our client.
I love it. I love it. I kind of think about this as the shock and awe slide, just a bunch of numbers with the sheer massive size of it, right? So Accenture, from an engineering size, how many engineers do you have worldwide, roughly?
So roughly about 125,000 software engineers working for us right now.
Holy moly, dude. Yeah. That is massive. I think that might even be bigger than Microsoft, all said and done. That's big. That's big. Okay. So why were you interested in kind of pursuing this research with us around GitHub Copilot?
So, as a company that invests very heavily in both our people and the technologies that they use to do their job, we're very interested, super excited about the promises of AI-assisted software delivery and really the changes that's bringing to the way that we all work day to day, right? So we had a lot of interest just in general in GitHub Copilot as the leading technology in that set of change. And really what we wanted to do was become what we consider a customer zero, right?
Yeah, all right.
So we like to first enable our own employees, our own workforce with the tool, and then we experiment with it at scale, right? Okay. Let them use it, then we learn the best way to do it, the best, how it best is applied in our industry, and then we can take those learnings back to our clients that we go and work with every day. And of course, we're also bringing that feedback back to GitHub to make sure that we're helping to drive the innovation with GitHub Copilot.
I like to think that we're getting better because of your feedback, so thank you. I will actually say here that is maybe a commonality that I've seen among some of the first adopters, that a lot of the organizations that adopted Copilot here in these first, 8 months that it's been available, they've been some of the largest engineering teams on the planet with honestly, some of the customers that would have been the most cautious or slow-moving in the past
Right.
have really jumped on AI. Now, my hypothesis here is that because the productivity gains there actually math out to be a huge amount of, well, additional value delivery, additional cost savings, and the like that you get. And so is that kind of the same thing that you see going on at Accenture?
Yeah, of course, that's the question on everybody's mind, right?
Right.
How much is this really going to save
What's
us?
it going to do?
How does it impact our delivery? And we started pretty simply. We just enabled a couple hundred of our internal developers,
Right.
and turned them loose with Copilot, let them use it as part of their daily work. And to be honest, our developers loved it. They came back to us. We had a developer that called us back in about 24 hours after we turned on Copilot for him, and he told us that not only was he using it as part of his day-to-day job, but it was saving him about 20% of his time just taking care of all of his unit test cases for him.
I was actually, we were talking about this backstage earlier, and so Dan was telling me, like, the developer had like a whole bunch of tests that were going to take like days to complete, and he completed them that afternoon, right? So
Exactly.
took some time off, got a coffee, maybe browsed the web, that kind of thing.
And we had a few developers that brought us stories like that, and so
That's
we knew
awesome.
that this was going to be a big change to the way we work and really impact the way we deliver software in general.
All right, well, let's look at the numbers here and actually see what results we saw out of this, right?
Okay. So, I mean, first of all, let me give you a little background.
Yeah.
We enabled about 450 of our internal developers with GitHub Copilot. We didn't give them any specific tasks to work on. We basically just said, continue doing your normal work, and, your day-to-day job as a developer. And then we observed that set of developers and
Okay.
their experiences over the next 6 months. At the end of the 6 months, we compared those 450 developers using Copilot to a similarly sized group of their peers that weren't using Copilot.
Right? Control, treatment group.
Control and treatment
Yeah,
group.
yeah.
So we tried to be scientific, but like you said, there's a lot of factors at play here. But what we found out that overall, the rate at which our developers were accepting suggestions from Copilot was about 35%.
By the way, that's in keeping with what we see with the population at large.
Right.
So that's
yeah,
good.
it seems
All
pretty
right.
normal. Of that code that was accepted by our developers, they retained a little more than 88% of the code that Copilot suggested after they did their review.
Okay. All right. So that's pretty good. So high retention rate. So Copilot was giving suggestions that survived edits, essentially.
Right. I mean, our developers liked the code that they were getting,
Love
right? We also saw a pretty dramatic increase in the number of builds that our developers were attempting. And overall, not only were we seeing more builds coming from our developers, but about 45% increase in the success rate of those builds. So we were also seeing, some increased signs of quality
Yeah.
of that code as our developers were using the tool more.
So increased throughput, increased quality. Now that's all around builds. I know we together monitored PRs as well, right?
Right. So yeah, we also saw an increase in the throughput of pull requests that our developers completed over that 6 months. So when they were using Copilot, they completed about 15% more pull requests.
That's crazy, dude.
Yeah,
That is absolutely crazy.
it's amazing.
So more throughput for the team, higher quality at large. Let's talk about what I genuinely care about the most, though. I'm all for productivity. Developer happiness, right? How do developers
happiness.
respond to it?
Right. So, we, of course, had the same question. We gave a survey to all the developers that participated in the study with us, and 100% of those that responded to the survey told us that they found Copilot useful.
Hot damn. All
Yeah,
right.
we didn't get a single negative comment. Nobody told us it was distracting. They all thought it was useful.
That's almost unbelievable. I'm going to be honest.
It is kind of
Yeah.
unbelievable, but get this, 50% of them told us that it was extremely useful
All right.
in their day-to-day job. So
That
I thought
warms
that
my
was
heart.
impressive.
That warms my heart. So now that we're through the research, what are you looking forward to next, kind of from this week, right, and from Copilot at large?
Well, two things. Number one, of course, we're going to be rolling out Copilot to all of our developers as quickly as we can, and we're super excited about that.
That's awesome. Yes.
So we're going to be much more aggressive about that. And of course, we're excited to continue partnering with GitHub, right, and offering some code solutions to our clients
Yeah.
to help accelerate adoption in the market. But personally, what I'm excited about, Ryan, I'm super excited to see where Copilot goes when we get it out of just the code editor and bring it into the rest of the software delivery lifecycle.
I love it. Well, we saw a little bit of that this morning. I've got some good news, though. I'm actually, over the next 45 minutes or so, we're going to see a lot more detail and depth in that. In fact, we're going to kind of like take a tour here through 3 different chapters. We're going to talk a little bit about developer experience. We're going to talk a lot about custom models, because I know that every single customer and developer that I talk to asks about how we can get more customization for these models. And we're going to take a deep dive into extensibility. For that, I actually want to invite one of the most terrific partners that we've had over the course of the last year, Harold, a product manager from the VS Code team, to talk a little bit about how we've been working on developer experience in the IDE together. Harold, come on out, buddy. Come on, let's do it.
Thank you, Ryan. And thank you to all the early Copilot chat adopters in the audience. I'm Harold, part of the VS Code team, and I'm going to take you inside and behind the scenes of Copilot chat in my editor. Let's kick off the demo. Small apps are fun for showcasing AI, but in reality, we all work on large and more complicated apps. I work on VS Code, so let's contribute to its open source repo. And here's our mission. VS Code's editor background recommends some must-have shortcuts. Let's add Copilot Chat to that list as an essential tool to anybody's workflow. Which chat style, though? In a typical VS Code fashion, Copilot Chat offers a customization interface that adapts to your coding style. Let's start by having Copilot on the left, but that hides the Explorer and other views I often need. Dragging it to the right and the secondary sidebar lets me keep it always on the big screen. I can also use Copilot Chat in the editor area for tab-driven workflow on small screens. But my favorite is Quick Chat, which I get from the Command Center or Command-Shift-I shortcut. It provides a keyboard-driven and minimal UI, keeping me in the flow. So I'll pick Quick Chat as the shortcut to recommend. And to be clear, this task won't be complicated. But often, even adding a simple feature can take hours out of your day as you try to understand the code base and figure out where things need to go. Copilot can help me do that so much quicker. So today, in Copilot Chat, I can explicitly mention add workspace to pull in relevant information from my code base. I'm going to get a rough description of what I'm looking for and watch the magic happen. Hey, let's hit the pause button, though, and delve into the nitty-gritty. How does Copilot actually get my code? AI needs just the right amount and the most relevant data for a given question. Copilot Chat achieves this with a hybrid approach. First, since my repo is on GitHub, Copilot taps into GitHub's knowledge graph. A semantic search returns relevant code snippets and metadata, and we're starting to roll this out to more users and more repositories. Next, to make the search work in any workspace, we layer in a local index, which runs offline even for uncommitted files. This uses a lexical search, which means it's fast and more exact. Finally, VS Code's language intelligence is the syntactic sugar on top. It has crucial details like function signatures, parameters, and even inline documentation. All of these are ranked, sliced, and summarized for the AI, making Copilot Chat an in-depth expert of any code base. So let's back to the action. Copilot tells me the relevant code snippet that ground its answer. Grounding improves accuracy of responses, but also makes them verifiable with links. After Copilot sifts through the code, it suggests starting in the watermark editor. That's what I've been looking for. Let's dive in. With the file open, Copilot can now help me make a plan. By default, it focuses on the current file, but I could also explicitly reference other files. There's another improvement at play here that is harder to show. And I can't have an AI demo without mentioning the word. So since recently, GPT-4 is used in all chat conversations. We still use other models, like GPT 3.5 Turbo, as its speed complements GPT-4's intelligence. This multi-model approach is informed by continuous experimentation to give you the cutting-edge AI with the feel of a lightweight, responsive tool. So back to my watermark file. I've got a rough plan of what to add where. I could do this manually, but let's have Copilot do it for me with inline chat. Hit Command or Control-I, and based on what I ask it, it now pulls in symbol definitions, surrounding code, related files, and more. The diff view is fully interactive with linting, hovers, and rich autocomplete. And since we added inline chat 9 months ago, its fan base has been steadily growing. Developers love iterating with AI directly in their code. So much so that since September, our early adopters have used Copilot chat more often inline than in the sidebar. Staying flow is key. Talking about flow, who here spends hours crafting perfect prompts for the AI just to get help? Yes. Flow these days is also about avoiding long, winding prompt crafting and code responses buried in long AI responses. Copilot has commands to solve that. To demo my favorite command, fix, I need some red squiggles. Let's rewind and say I had attempted to write a new entry myself and got the types wrong. In any chat input, here with inline, hitting slash gives me a list of commands. These are shorthand for chores and even longer workflows. Allison demoed some of them, so let me close this and show you an even faster way. Fix is just a click away on every red squiggle. Open the Code Actions menu or hit Command dot. And fix is not just a well-tuned prompt. It pulls in related problems like linting errors, looks up code from stack traces. It retries if the AI missed arrows on its first pass. It's a lot of power behind one command. Not surprisingly, fix is Copilot's most used action. So let's see how our change looks. I'll run VS Code from source, and here is our new favorite shortcut. It's a good time to commit with Copilot coming along. Check out that magical Copilot button. One click, and I have my message ready. I save time and can go right back to coding. As I add it to this file, I do want to leave it a little cleaner. So commit, and this time, I'm controlling inline chat using my voice. Hit the microphone button or assign it a shortcut. Manage entries as collection of key value pairs. Sweet. Real-time preview looks stunning, and more importantly, gives me time to double-check Copilot's approach. So let's iterate with a follow-up. Rewrite entries to be alphabetically sorted. Clean up like that would have taken me several minutes. With Copilot Chat, it's done in a few seconds without typing. And back to committing. As you might notice, you will probably commit more often, even without thinking about it. But why stop making commits easier? Copilot knows about my code and what I've changed. It even drafts a PR title and description for me. And that is the real power of AI in your editor. Removing that tedious, busy work we all must do. A tax on productivity that we no longer have to pay. And when I get that review with a suggested change, Copilot can address that too. Even though AI suggestions are just a click away, I'm still in charge of reviewing and iterating with Copilot. And there are many more smart actions saving you time in all areas of VS Code when Copilot is installed. In a terminal, Copilot Chat suggests commands. In Jupyter Notebooks, it fixes runtime errors. It even powers a smarter search in command palette and settings. Customization, extensibility, and accessibility are what VS Code users love, and AI is part of it. So this was my behind the scenes of the 3 major updates: how Copilot Chat gains expert knowledge of any code base, how GPT-4 is one of multiple models it picks from, and how Copilot infuses AI in every aspect of your developer workflow. All of that, everything, is available today in VS Code's Copilot Chat. All of these you will also find in Visual Studio, and JetBrains is ready for you to preview via waitlist. Thank you, and happy smarter coding.
All right, yes, cool. So we've heard a little bit about developer experiences. I promised a good deep dive into custom models, and so let's do it. Like I said, every single conversation that I have with a developer invariably goes into how can you personalize these models? How can you create them so that they're genuinely learning, adapting to me and my team's preferences and styles and all that good, crazy stuff? Well, we've been doing exactly that for about the last year, experimenting with GitHub and Microsoft's internal repositories and our internal engineering teams. We've learned a few things. Through fine-tuning, and just fine-tuning alone, we can convince these models or tease these models into doing some pretty cool things. We can improve the overall suggestion quality, right? Improve the acceptance rate and the characters retained by delivering more relevant suggestions. We can introduce bias into the models so that they show a preference or a bias towards our preferred API version numbers, SDKs, libraries, and packages, so that the models feel a little bit more, at home for your engineering team. And there are many times where teams might be working with genuinely unique code bases that are not well represented in the foundational models. This comes in a couple of different flavors. Sometimes it's really old code, frankly, sometimes. It's like COBOL and Fortran, stuff that wasn't really well represented in kind of the cloud-based repositories where a lot of the original training data comes from. But can also come in for organizations that have their own proprietary languages for really specialized purposes, right? Now, you might be asking yourself, how do you do this, right? How do you actually fine-tune these models? Well, we've got 3 kind of categorical approaches that we take to this. So first, we take a look at your repository data. And yes, that means your code, right? But, we all have code in our repositories that we're proud of, and then there's some code that we're maybe not so proud of, right? It happens, it's cool. Usually, that code that we're less proud of, it's code that's been lingering around for a while. It's maybe code that we wrote 3, 5 more years ago. And so what we do is we introduce kind of preference or bias into the models for the more recent PRs that were merged, under the kind of the assumption here that whatever you're merging today likely passes muster for your organization's best practices. We also use signal coming back from the suggestions that we're presenting to you in the IDE. Because, if you're presented a suggestion and give it the thumbs up, accept it in your code, that's probably a good signal that it is worthwhile code. If you pass it by or move on to the next one, it's probably a good signal that that was not great code, at least not for your purpose. And turns out that signal, that telemetry that we get from developer activity, there's a lot more of it. There are hundreds or thousands of decisions being made every hour, every day, and that volume of data can really, really benefit the fine-tuning algorithms. And last, we use reinforcement learning from human feedback, right, in order to essentially build an in-between model. You can kind of think of it like a sentiment analysis on suggestions that sits in between the large language models and the IDE to sort of filter out suggestions that may be good or may be bad. And all of these techniques together, we've seen significant uplift in our own internal experiments. But you know what? It's not enough just to experiment on ourselves. And we do, we like to drink our own champagne, eat our own dog food, as it were. But you really needed to diversify the number of data sets that you work with. And so for that, we looked to a few trusted external partners in order to continue our research. So one of those is AMD. And for that, I want to invite Alex out on stage to talk a little bit about our research together. Come on out, Alex. Yeah. Woo.
Hey.
I love it. I love it.
Hey, thanks for
Welcome,
having me.
my friend. Welcome. Yeah,
Thank
dude.
you for having me.
All right. Well, so we're here. Tell me a little bit about kind of like AMD and what made you interested specifically in exploring this kind of research with us.
So at AMD, we build the hardware that runs all your applications.
Yeah.
Right? Part of it is hardware design. Part of it is software development to put together a system. Right? What we found is Copilot is great. It works wonderful on Ruby.
You're
on
just
Python,
flattering us now. You're just flattering us now.
on
though.
JavaScript. So basically, if you're doing web applications, you're golden, right?
Yeah,
Like,
all right.
totally. But it doesn't really work well on lower level languages. And if you asked me last year, it didn't work at all on hardware description languages such as Verilog or System Verilog. And this is where we started talking and we decided, okay, let's do this and figure out how do we solve this challenging problem, right? So
I love it. I love it. And so, like, as we were approaching this, I know that like one of the things that I've known about hardware developers for a long time and device driver developers is that they love their Vim and they love their IDE, right?
Yep.
Now, fun story about this one. So when we're conducting our original experiments, we needed to work inside of an IDE where we could have good kind of telemetry feedback. And so we kind of required developers to use VS Code specifically for this experiment. What happened?
Well, I mean, if you ask your friends who are diehard, Vim supporters, right, switch. What do you think the answer is going to be? It's going to be,
Hell no.
you'll pry it from my cold dead hands, right?
Right.
So, but in this case, the power of the model that we developed was actually compelling enough for some of them through that period of time to switch to VS Code to use it to get the fine-tuned model results, which it blew my mind.
Yeah. I mean, like, shows the power of curiosity and shows the power of maybe the potential of the large language models here.
Exactly, yeah.
And so as we were going through it, what was your team's experience with kind of the fine-tuning exercise? What sort of results did you see?
So you kind of touched on fine-tuning and the general process. Let me give you some color. Like
Please,
what we
yeah.
saw. We started with, identifying representative code, and then we gave that to GitHub to do the fine-tuning, right?
Okay.
So in our case, the code consisted of Verilog, System Verilog, and C.
Okay.
What we found, a couple of weeks later, after the initial, I would say, exercise, is that AMD had a custom, private Copilot model that worked better on some of our specific languages, right? So just to describe the experience, so that Copilot experience that you guys all love, right? It's autocomplete, it's getting the next line, it's doing documentation. So imagine this now working on Verilog, where a year ago we could dream about that. So that's kind of number one, and that's really early results. We continued optimizing, like with your team
Did
throughout
around with
this.
telemetry.
Yeah, with telemetry, and we found two very, very cool things, I think.
Yeah.
Right, so the first thing is that the style of code that we got from the custom fine-tune model was actually more in line with what our engineers produced at AMD, so more like AMD-like style of code. And remember, I said, hey, we gave some C code, right? And you may wonder, like, why? Like, we want to enable Verilog, so why give C code? Well, Copilot current, product in the market supports C, so it gave us a good baseline. So through internal polling, through some of the surveys, we found there's actually significant preference to go to the fine-tuned model even with C than the vanilla model.
Yeah.
Let's put it that way. So that was great. And I guess if I were to maybe unfold it a bit further, the potential here is that we can have multiple Copilot models. They're domain-specific per team and their style of design, right? Maybe it's a firmware team, maybe it's a software team, maybe it's a web development team, right? And that could be tailored to them as the best possible Copilot experience. So that, to me, was very powerful.
I love it. And in fact, over the last several months, a lot of what our team has been working on is really re-architecting the back end of Copilot because we foresee a world that is not a single model world. It's not a single generic foundational model for everyone, but is rather a multi-model world where each organization, nay, even each team within an organization, if they've got different set of onboarding docs or a different set of kind of standards and practices that they work against, it will be a multi-model world where we're each matching the model against the job to be done or the task that we were doing that day. Right?
Yeah, and even this early kind of results, they show that already.
I love it.
At least in our experience. Now, the second thing actually blew my mind. And you see a quote up on the screen. It was made by Thomas, who's one of our engineers. It blew his mind, right? And then when we were talking to him, he said, hey, this is really cool. So in order to introduce it, I have to explain a little bit and draw a parallel between software developers and hardware developers. Okay. And guys, let me know. I'm assuming most of the software developers here, you want to run quick, you want to iterate, you want to get to your minimum viable product, you want to prototype, you want to just rebuild, you have your CI/CD set up, right? Does that sound all right?
Yeah, yeah, all right.
When you make introduce a bug, what's really the cost of that? Well, just fix the bug, spend a couple of minutes rebuilding, redeploy, boom, off you go, right? For hardware design, it's a little bit different. The logic that these guys do, it's, tiny wires, smaller than your hair, printed on a piece of glass, going through a factory for months. So at that stage, if you make a bug, you can't just hit a rebuild, right? Your rebuild means that months are lost and millions of dollars are wasted on a respin.
You got to go back to the factory.
That's your rebuild. Yeah, exactly.
Go back to the factory.
Right. So that's all to say that the hardware guys are really, really good at writing requirements and writing specs because they don't want to, they don't want to do this whole factory cycle thing, right? So in AMD process, oftentimes, they write plain English specs, right? So on this screenshot, you actually see a spec for a USB 4 router state machine, right? But it's not just a spec. This is actually a Copilot prompt, right? This is actually the cool thing about it. So our engineers took this verbatim, copy-pasted into the IDE, added the first line saying, hey, generate me a Moore state machine, and added one more word in the middle, says this is where transitions start. The rest of it is absolutely unchanged from the spec. And what came out, if you want to fast forward to the next one, is a pretty accurate set of Verilog code, right? So imagine this, right? So a product development cycle, now you can automate part of this, translation from plain English into Verilog, and shorten directly our product development cycle. So that was just unbelievable.
That is trick. That is trick, man.
Yeah.
Well, I love it. I love it. Well, I thank you so much for doing this research with us, and thank you for advancing it really for everyone here. So private models are available via waitlist on GitHub.com. We do hope that more partners will come and research with us as we bring it to market here in the coming year. Now, fine-tuning is one way that we deliver customization, but there is a whole world of additional data that exists outside of GitHub.com. It is in your Splunk and Datadog instances. It's in your LaunchDarkly instances. It's all these other places, all these other tools that you are using for development where Copilot is essentially blind until today. So for this next portion, I really want to invite onto the stage Shuyin to talk about how we were expanding the GitHub platform to invite all of you to integrate and develop and to create an AI-based economy with us. With that, Shuyin, come on out. Thanks.
Thank you.
Thanks, Ryan and Alex. How amazing is it? Now Copilot can customize code suggestions tailored to your code base. Imagine how much productivity boost that can unlock for our developers. Really exciting. What if we extend that even further? Not only we customize for you, but also invite you, the entire developer community, to build and customize Copilot together with us. That is what we envision the future of Copilot to be. An ecosystem with marketplace of plugins, integrating with third-party developer data, tools, and services. Together, we can innovate, reach millions of developers all across the world, and transform the way the software is being built, and elevating GitHub Copilot, the AI pair programmer, to assist all aspects of developers' workload. So deeply engaging with the developer community and building product together has been our success recipe. And we would like to use that recipe to build our collective success, and maybe the greatest one yet, together. So across Copilot ecosystem, as one grows, we all grow. So what do we mean by extensibility, and how do we build the ecosystem together? So building on the fine-tuned capabilities that Ryan talked about, the Copilot extensibility enable customers to further personalize your Copilot experiences through two high-value scenarios: expanding Copilot context and knowledge, and extending capabilities. So today, I will walk you through a few integration examples. We hope by sharing these examples, we can get you energized, unleash more creative ideas that we have yet to imagine. So together, we can innovate and unlock the most value for our developers community. So first, expanding Copilot context and knowledge by bringing your own data. So in the broader world, and every business is software business that's built by developers. So within each business organization, developers need to build with internal guidelines, documentations, or business-specific context. And I'm sure folks in this audience all have experienced the pain of spending time searching through documents scattered around multiple places just in order to find the most relevant and up-to-date information. With the ability of bringing your own data, the pain will go away. And now developers can access all the relevant information from the singular place, Copilot Chat. So let's walk through how this will work. Let's say I run the internal GitHub engineering system. So there are a set of documents created over the years that cover the best practices like common engineering patterns or incident review processes. And I want every developer in my org to get Copilot suggestions that are tailored to this knowledge. So how do I bring this private info to Copilot? So as a GitHub platform customers, I can just log into github.com and follow the onboarding steps. So first, create a doc set and give it a name. And set the visibility to private, so only people in your organization could access to it. And second, select the list of repos where the docs are being stored. It could be single repo or multiple repo. And just like that, and now I have registered a private doc set for Copilot to reference. So for developers in my engineering org, they can just go to Copilot Chat to ramping up an internal GitHub engineering system and asking questions like, what is Kubernetes, which is an internal GitHub tooling system for managing and provisioning Kubernetes? And also asking questions like special best practices, like how do I prevent CSRF happening in .com? And Copilot answer given to me is very GitHub-centric. So a very straightforward process is for a very powerful scenario, right? So what happens behind the scene is the creation of the doc set kick off an indexing pipeline that create the embeddings and store them in the vector database. So when the user's queries come in, Copilot retrieve the required snippet and use it to ground Copilot answers. So what's being played here is a very popular generative AI tag, retrieval augmented generation, RAG. I'm sure folks in this audience all know about that. So besides RAG, the Copilot platform also does the groundwork to optimize the storage and query performance, so ensure Copilot responded users in a prompt way. So that is one of the two high-value scenarios of Copilot extensibility, expanding Copilot context and knowledge by bringing your own data. The other high-value scenario is extending Copilot capabilities through building plugins. So developers today, they have to work across a variety of tools, like editors to write code, database tool to manage data, CI/CD tool to manage deployment, observability tool to like monitor service health. So there's a lot of context switch just to get the job done. So with Copilot plugins, this will change. So for integrators, by building plugins, you bring your tools and services to where the developers are. For developers, by accessing your tooling need from the singular place, Copilot Chat, you get further productivity boost. So there are two types of plugins, an SKU and an agent. So integrators can register them with Copilot platform and have the choice of making them public for everyone to access, or private, only available for people in your organization. So let's first demonstrate the new capabilities that the SKU enables. Let's say I'm a developer working on K-means clustering project, and during unit test, I find a bug in the code. And I can just ask a Copilot to create an issue for me. And the Copilot has the intelligence to summarize the issue based on the editor context, like arrows and relevant files, and pre-populate the GitHub issue template with a summary. And all is left for me to do is to review and click create. It's like pretty magical experience to accomplish all these steps with just a few simple natural language instructions. So what happens behind the scene is when a user makes a request in the chat, it hits this intelligent layer that does the intent detection and pulls in the first-party and third-party SKU plugins as necessary. So in this particular case, it identifies users wants to create a bug, so it's select and invoke the first-party create GitHub issues and summarization issues to complete the task. It's also worth noting that the create GitHub issues is an example of a first-party SKU plugins that we're building to expose the rich GitHub capabilities. So out of the box, all of the Copilot users will get access to these first-party GitHub plugins that are naturally composed with third-party ones. So that's SKU plugin. So for integrators who wants to have a greater control over the user experiences, and you can do that too with agent plugin. So let's see how the agent integration experience looks like. So DataStax is a database service provider. Through the agent plugin, DataStax developers can now directly access all the application-specific data from a singular place, the Copilot chat. And they can ask questions like, tell me more about my database, what tables are in this database, and how do I query this database? So they don't have to go to a separate website to manage the data like what they do today. So again, really keeping developers in the flow, meaning like further productivity boost. Another like magical experience enabled by this agent plugin. So how does this experience work? So our partner at DataStax, they developed this agent plugin that connecting the Copilot chat with the Astro DB web service and register with Copilot platform. So when the users issue the query, Copilot platform invoke the DataStax agent plugin, which knows how to interpret the user's natural language queries and calls the right API to complete the task. So a very seamless integration enabled by the agent plugin. It gives the integrators the full control over the user experiences and also the flexibility to define the type of functions and capabilities to bring to Copilot. So to recap, we just went through a few integration examples of Copilot extensibility, expanding Copilot context and knowledge by bringing your own data, extending capabilities with plugins. So hopefully, by sharing these examples, we get you energized by the endless opportunities ahead of us. So as we embark on this new journey together, we also must acknowledge the potential risk that come with it. Powerful new technology require us to be more thoughtful and proactive. So at GitHub, not only do we committed delivering high-quality product, but also we stay true to the safety, security, and privacy core principles. So we'll be publishing guidelines, best practices to our integrators, and review the plugins when they are brought into Copilot. So want to take the flight with us? Be sure to apply for the GitHub Copilot Partner Program. Let's shape and build the future of Copilot together.
Awesome. Well, thank you so much for joining us on this tour and deep diving into developer experience, into custom models, and into extensibility with us. Building the future together is such an important piece of this. But there are more people than just the folks here in this room and the folks in the audience for us to thank here today. Shuyin.
Yeah, so before we end today's presentation, we would really like to give a big shout for every Copilot team members, folks in GitHub, Microsoft VS Code, and Azure OpenAI. It's truly a privilege to represent everyone's hard work on the stage. We would also like to take a moment to thank you, the entire developer community, listening to your feedback, seeing your posts about what you love, what features you're hoping for, what could be better. This has been the through line of what's motivating the team. So on behalf of the entire Copilot team, we hope you enjoy using Copilot as much as we are building it. Wonderful. Thank you.
Thank you.
Yeah.